What we want to point out is there are no parachutes for the Orion test article, and that's intentional.
Right.
Explain that really quick.
So the parachutes have been through a very robust test program. We've had 49 drop tests, an extensive ground test program, and 2 end-to-end tests on Exploration Flight Test 1 and Pad Abort 1. Since A2 wasn't going to be a stressing case for the parachutes, they decided they weren't needed.
All right. And so the Orion test article will fall to the ocean and will sink after the test is complete. Now, the test of these motors is a high-flying, fast-paced trial without any crew aboard. And as you're about to see, it all begins with the launch of a test booster that will send the Abort system and the Orion test article 6 miles up into the sky. At the top is the Launch Abort system. At the bottom is the Abort test booster, a solid rocket motor enclosed with an aero shell built out to the width of the test Orion crew module above it. Engineers want to test the Abort system while it's in flight, so the booster will propel the 46,000-pound Orion test article to a speed over Mach 1, about 800 miles per hour. 55 seconds after launch, and at an altitude of 31,000 feet, the abort sequence begins. With a lift of 400,000 pounds of thrust, the abort motor will pull the test Orion away from the booster, propelling it more than 2 miles in just 15 seconds. At 43,000 feet, the attitude control motor at the top will position the capsule to prepare for the safe separation of the crew module. At 44,000 feet, the jettison motor fires. As the test article falls, 12 electronic data recorders will repeatedly write and back up the test data until they are jettisoned from Orion and will later be recovered by boat. So it truly is going to be an exciting test flight to watch. Now, Orion will enable humans to pioneer farther into the solar system and continue our journey to Mars. Mark Kurasich, Orion Program Manager, explains why Orion is a key element of NASA's plan to return people to the surface of the moon by 2024.
Good morning. I'm Mark Kurasich, Manager of NASA's Orion Human Spacecraft Program. 50 years ago, NASA was preparing to launch Apollo 11, the mission that took people to the surface of the moon for the very first time. Today, we continue progress on our generation's human space exploration program with a major milestone in Orion, our Ascent Abort flight test. Orion is a key element of NASA's plan to return people to the surface of the moon by 2024. Taking people this far into deep space is no easy task, and Orion's team has incorporated many safety features into our design, which protect our astronauts and minimize risk during their journey. Today's test will demonstrate one of those systems, the Launch Abort system. This system protects the astronauts during the first part of their flight, and today we're going to test it under some of the most demanding conditions Orion will ever see during ascent. While we're out here on the test range today, we also have hardware and software and manufacturing and assembly and test at factories and labs around the world. For example, just a few miles up the road from here is the Armstrong Operations and Checkout Facility, Orion's final assembly factory. If we walked into the ONC building today, we would see a beehive of activity as the Artemis 1 crew module and service module are nearing completion. We're also well underway with manufacturing of the Artemis 2 crew module and service module, both here in the U.S. as well as in factories in Europe. And we're initiating long lead procurement for our Artemis 3 vehicles. We have a lot going on. And while we're doing all this, we're also working with our partners from the Space Launch System, Exploration Ground System, and Gateway programs as they make similar progress on their march to first flight.
A lot of activity going on with Orion right now. And look at the crowd there on the pier out there at Port Canaveral. Packed right there on the edge of it. Everybody standing there and looking northward to watch this launch
happen. It certainly is a lot of excitement here on Florida Space Coast as we get ready for launch. And there you can see the sun shining on one side of the flight test vehicle there on the pad. Now, the next time the full launch abort system flies, astronauts will be on board. Today's test lets us make sure the launch abort system performs as we expect it to during our climb to space. Astronaut Randy Bresnik now will tell us what he'll be watching for during this critical flight.
It's amazing to think about flying on Orion, and every current astronaut and every future astronaut that's looking at Orion and our effort to go back to the moon by 2024 is exceptionally excited at the opportunity to fly on Orion. To take humans beyond low Earth orbit, the Van Allen radiation belts, and transverse 250,000 miles to the moon is very exciting. And you think of the most dynamic and probably some of the most difficult, dangerous parts of the mission are really just get in and out of the atmosphere here on Earth. And so that's where Orion is going to be flying, and that's why this launch abort system that we have is so important, because it allows us that safety measure, that backup system in case there's any problem with our launch rocket. So the real purpose of this test is to prove that the system works, right? And why does it need to work? Because you've got the world's largest rocket ever made by humans, the SLS, the Space Launch System. And for a vehicle that has a problem, that rocket, if there's an explosion or some other type of vehicle anomaly, this launch abort system has to be able to outrun the most powerful rocket ever built by humans. So it has to be exceptionally powerful. And it is unique that it is the most powerful and the fastest accelerating abort system motor ever tested.
And you got to have the fastest motor to get that capsule off the top of a rocket, which is the most powerful rocket ever built that it'll be flying on. We're T-minus 8 minutes and counting, everyone, as we get ready for the launch of Ascent Abort 2 and the flight vehicle there at launch pad 46. You can see the many views that we have here. Now, before today's in-flight abort, NASA conducted a pad abort test in 2010 from the White Sands Missile Range in New Mexico. I want to take a look at that video. Here it is. You see it gets off the pad quick. Tracker cameras captured the abort motor firing a momentary 500,000 pounds of thrust to propel the Orion crew module away from the pad. The module reached a speed of approximately 445 miles per hour in the first 3 seconds, and then a max of 539. And there you can see it reorienting the capsule, getting it heat shield first before it released it, and then it came under parachute. The successful flight test lasted a little over 2 minutes, and the parachutes were successfully deployed before the crew module landed about a mile away from the pad. This time, though, we will have a booster, and the intent is to fly that booster and that test article to maximum aerodynamic forces to check it at a time where it can really get a full test of what it would be like under the most stressful loads. Ashley, we're looking good so far for the count, right?
That's right.
Just a few seconds now, we're going to get the final launch authorization poll, which is going to happen right now. Let's listen in.
30 seconds and counting it. CLC requesting final authorization for launch. All stations report go. LD.
LD go.
Rock.
LDA has issued clear to launch.
Copy that. Check step 76. TC, FTA is go for pyro arming.
Proceeding.
PCC at the power control console fail-safe switch. Verify the following.
Ground ordnance is green.
Check step 78. PCC enable ground ordnance.
Ground ordnance enabled.
Check step 79. DM verify ODM bus voltage enabled.
ODM voltage enabled.
Check step 80. PCC verify PLO power is go.
PLO power is go.
Check step 81.
Looks great.
And so what we're listening to now is they switch the vehicle from external to internal power and get the flight computer ready?
That's what's happening next. Yes.
Okay. And so everything's going to proceed well with there. We're going to listen in as they get this flight vehicle ready to go.
The motor is armed.
T-minus 5 minutes and counting. PCC, switch avionics internal power on.
Avionics internal power on my mark. 3, 2, 1, Mark. Internal power on.
Check 82, PCC, switch avionics, external power off.
External power is off.
Check 83, VC, enable flight computer auto sequencer start.
Auto sequencer enabled.
Check step 84.
LC, all FTA pyros are armed.
Copy that. TC, check step 77. And all stations were currently complete through step 84 of the ATB final launch checklist. Standing by step 85 at T-minus 4 minutes.
All right, and so the count proceeds. Everything's good to go. We are T-minus 4 minutes until launch. Ashley, let's talk about once we hit T0, the expectations for what we'll get in the plus count as it goes up.
So during the plus count, we'll hear the flight test article guidance, navigation, and control operator call out key milestones. We'll listen for the vehicle's altitudes and speeds, and he'll call out when the abort has occurred and the phases of the abort. We'll also hear the test conductor call out the data rebroadcast of the telemetry and the end of the flight test.
All right. And so that's good to know. Also, another expectation that we want to let people know is there, again, not going to be any parachutes on this flight test coming out of the flight test article, which is a mock, it's Orion, but it's a simplified version of it.
That's right.
And so once Orion is released from its LAS, it will come down all the way to the ocean, and we should not see any parachutes because that's not part of the test.
That's right. The only thing that will happen at that point is it'll eject data recorders that are recording data for the mission as backup to the telemetry.
Right, and so it's interesting, the test actually ends before Orion hits the water out there in the ocean.
Yep.
Because it's really the data that they want. They want to see 900 sensors or so on board this particular flight test article that will be taking in data, as you said, transmitting it in real time, and then writing it to those EDRs, those electronic data recorders, and then sending them out. We're going to now get back to the count. 2 minutes and 16 seconds to go. Just a few minutes away from this exciting flight test here on the Space Coast. We're going to listen in as the launch conductor continues to work this launch with his crew.
This is the LC, T-minus 2 minutes and counting. VM verify flight computer auto sequencer started.
Auto sequencer started.
Check 89 BLC, verify T-minus 2 minute limit checks are go.
Limit checks are go.
Check 90 PCC, set arm enable.
Arm enabled.
Check 91 PCC, arm TVA gas generator AD.
AD switch armed.
Check 92 PCC, arm stage 1 ignition SNA.
SNA armed.
Check step 93. Step 94, TC, confirm launch timer clock is running.
Launch timer clock is running.
Check 94, BLC, start LCR Dewey.
Dewey started.
Check step 95. T-minus 1 minute and counting. And T-minus 45 seconds and counting. VM verify stage select activated.
Proceeding.
Copy that.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1, ignition. And this is the LC Minotaur launch vehicle is carrying the AA2 launch abort system for a full express test.
seconds, we will see the abort.
Abort initiation.
Pyros 1 and 2 discharge both sides.
Bridge for pressure.
Good control. Reorientation. Settling phase. Jettison.
Pyros 3 and 4 discharge both sides.
Squib power enabled.
So there goes the LAS, tumbling a bit. Orion coming down.
Start of data
Everything looking
rebroadcast.
good so far.
Recall there are no parachutes on this test today, so once the data recorders have been deployed and the vehicle is no longer transmitting data, TC will call test complete.
And we're looking now at the Orion. That data is being written. We're about to get ejection of those EDRs. It's tumbling a little bit. That was expected.
As expected.
Second rebroadcast.
You just heard there, the second rebroadcast that continues to write that data. And now we're awaiting confirmation that the test is complete. And it would appear that the test is complete. And
Beautiful.
yeah, and so Ashley, there you go.
Yes,
And
there it is.
there was the official word. And a beautiful shot there from Port Canaveral, where the launch took off, and you can hear the launch conductor congratulating his team. Ashley, what did you think about this test? It looked good from here.
It looked beautiful from here. I think that was excellent. We could not have hoped for a better kind of day. It's just wonderful.
And here at the MDC, just behind us, as the test was beginning, and then once the launch abort system pulled away, you could start to hear everyone clapping and cheering here at the MDC. It must be a good feeling.
Yeah, absolutely. I mean, it's been such a special opportunity to work on this mission that's going to enable our astronauts to go to the moon and beyond. And to be here today and be able to share it with the public with you, it's wonderful.
Great opportunity for all of us as well. And there you see the crowd out there on the pier that gathered to watch, starting some of them to make their way back off. That's the Jetty Park Pier over there at Port Canaveral. And that's a long pier. It looks condensed in this shot, but there are a lot of folks there that gathered to watch this, as I'm sure many people did up along the Space Coast. Want to talk about what's happening next. The test data from this particular launch was broadcast by the flight test article out to receivers that were coming in, and now you'll get that data, you'll be able to look at it. But in case that data doesn't come through, you have a backup system.
Right. So in case there's any kind of dropout in the telemetry, we had a backup system. The ejectable data recorders are these little devices. They would be ejected from the CM, as you saw, well, as we talked about. They have essentially a USB drive that recorded all the data. There is a GPS receiver that's letting it know where it is. Then there's an antenna so it can tell us and the recovery boats, hey, I'm here, come find me. It is then all packaged in this syntactic foam, which is these little micro balloons in an epoxy mixture to keep it buoyant. They have it weighted so that it keeps the antenna up and broadcasting until we can pick it up.
And there's 12 of them that came out, right?
12 in total.
Of the Orion test article. And, in fact, on the front of it is a telephone number and an email address.
That's right.
Just in case we're not able to pick them up. But the beacon will be transmitting, and we'll have boats out there that will be looking for these to pick all 12 of them up. It's possible one might elude the crew out there, and if it does, and you find it, give us a call.
Please return it.
We'd like to have it. So that's a neat little backup system that was put in here. And I think you were telling me there's a shotgun, something that's equivalent of a shotgun shell that shoots it out.
That's right, yeah.
Right. And so we got confirmation that that those were ejected from the test article as it was falling back down. Now the work begins to go and collect those. As far as the Orion crew capsule, the test article is considered, as we look out at a view there out eastward into the Atlantic Ocean. That impacted the water at roughly 300 miles per hour. As we mentioned many times, there was no intent to use parachutes on this particular test article because it was intended to sink. How did they make it so that it would go down instead of having, parts floating?
So the vehicle will break up on impact. And if there are any concerns with any floating debris or pieces that do not sink immediately, the vessels that are out collecting the data recorders will make note of that, and either they will pick them up or other vessels will go out to either sink or pick them up.
All right,
so that they are not a hazard.
And the crews are likely taking off from right there in Port Canaveral to go and pick up those EDRs that are out in the water right now. And as she said with the Orion, it was intended to break up. It's an aluminum structure.
That's right,
and,
for the test article.
You were showing me some engineering diagrams that shows how it breaks up intentionally, and it goes straight down and becomes a reef.
It does.
Yeah. And there's no harm to the environment in any of this. They researched that as well.
That's right.
To make sure that would not happen. Now that the flight test is complete, we will have a briefing to go over some of the preliminary data that was gathered during this flight test, and that will be given by the NASA launch teams. We expect Mark Kiersich will be part of that. We also expect him to come by here at the broadcast booth and stop by and talk to us about his thoughts on the completion of the test and how it performed through his eyes. He is the overall program manager for Orion, which, as he has said, and if you were watching earlier in our show, it is a busy time for Orion. We have several capsules that are getting ready for the next few missions, Artemis 1 and beyond. And so those are in preparation, and this is another step towards getting us closer to that goal of landing the first woman and the next man on the moon. And so as that continues, we will continue here with our broadcast. You're looking eastward out at Launch Complex 46, and it is a beautiful morning. The Orion team conducted a successful test of their flight abort system, the launch abort system, which in the case of an emergency with the rocket could successfully pull Orion off the top of the most powerful rocket in the world, SLS. That's important because in order to move off of the top of the most powerful rocket in the world, you've got to have one powerful launch abort system, and that's indeed what was tested today. It appears that it was a successful test, and to confirm that, we have now here at Hangar AE in our studio booth, Mark Kiersich, Orion Program Manager. Thank you for joining us. And congratulations on the successful test.
Yeah, thank you, Daryl. Good morning. Yeah, everything looked really good. We're, of course, just looking at the data, quick look data, but the abort motor fired, the attitude control motor, the pressures were fine. We saw the pinwheels moving, the reorientation, all the GNCA data looked good. So it'll take us a little bit while, but by all first accounts, it was a perfect test.
That's awesome. Let's take a look at a replay of the launch, if you will, and kind of talk us through what you saw as you were sitting on console. You've been here since 1 in the morning, as your entire team has, doing the 6-hour-plus countdown. And here we have it.
And the first thing is the weather, the skies. You know, we've been here for a couple weeks simming and training, and we've never seen blue sky. So the weather was beautiful today. There's the The SR-118 motor kicking in.
Smooth liftoff.
Very smooth.
And you weighted that down because, as Jenny was telling us yesterday, it's a pretty sporty rocket.
Yeah, it would have gone too fast. We had to add about 100,000 pounds of ballast. So the booster targets a certain dynamic pressure and a certain speed for us to initiate abort. And again, the quick look data looks like they hit the target right on. It was a little bit over 52-ish seconds or so. Nominal is supposed to be 55. We'll get the data to tell us exactly when.
There's a close-up shot, and just about getting ready to see that launch abort system pull Orion away.
Correct. The big motor, 400,000 pounds of thrust is going to. There it goes.
There it is.
400,000 pounds of thrust. And now you're going to start to see the attitude control motor at the top is going to start to pitch the vehicle over.
And as you look at that, it is
There it
oriented.
goes.
There it is. Getting
There's
that
the
heat
pitch.
shield forward, right?
Yes, exactly. So when the jettison motor fires, the crew module drops out and it's pointed in exactly the right direction. And that was the data point we wanted to see the conditions, if you will, when the crew module dropped off. And there it was, jettison motor, and here's the crew module descending, just like we planned.
Perfectly. And there you see the launch abort system tumbling away. Orion, the test article, started coming down. No parachutes here, Mark, and there's a reason for that.
Yes. We simplified the test article. We wanted to get this test done as early and as quickly as possible. We're going to use the results from today to inform our planning for the first human flight, Artemis 2. So we wanted to get this test done quickly. We simplified the crew module test article because it was all about the launch abort system today.
And it performed pretty well.
By all accounts, it was magnificent.
During that point, the EDRs were ejected, and so you've got your preliminary data. You'll be able to go over the broadcast data that was sent to you, but then you've got those EDRs as a backup.
Yep. The team's going to take a couple hours this morning. We'll get quick look data report number 2. And then it'll take a couple of months to go through the detailed data. And we'll look at everything, all of the pressures, the flight trajectories, the internal motor parameters to make sure everything worked just as expected.
And now, you've mentioned this a few times before, where does this take us? Once you've got this successful test under your belt, what are you looking towards now?
Well, we have a total, before we fly humans for the first time on Orion, we have a total of 4 flight tests. 2 abort tests. With today, we are done with flight testing the abort system. We flew Exploration Flight Test 1, which was an orbital flight test. The next flight is Artemis 1, a little over a year from now, which will be the Orion crew module returning to the moon.
And that'll be exciting.
Yes.
And then Artemis 2, which will put the first woman and the next man on the moon.
Yes, a great step forward today for the team.
Congratulations again, Mark, to you and your team. Great job. It was fun to watch for all of us here, both in the MDC at the Hangar AE as well as out there along the Space Coast. I'm sure we all enjoyed seeing not only the show, but also knowing that it was a success.
Yeah, thanks, Darrell. And thanks to the Orion team. Great day today.
Congratulations to all. And that's going to conclude our coverage of Ascent Abort 2. For Mark Kirisich, Ashley Tarpley, and for all of us here at NASA, thank you for joining us. We now leave you with replays of the flight test from a number of different camera angles. And remember, keep looking up.
For launch. Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1. Ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.
seconds. We will see the abort.
Abort initiation.
Pyros 1 and 2 discharge both sides.
Good chamber pressure.
Good control. Reorientation. Settling phase. Jettison.
Pyros 3 and 4 discharge both sides.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1. Ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test. Mach 1.1.
Okay, about 10 seconds. We will see the abort.
Abort initiation.
Pyros 1 and 2 discharge both sides.
Good chamber pressure.
Good control. Reorientation. Settling phase. Jettison.
Pyros 3 and 4 discharge both sides.
Squib power enabled.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1. Ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test. Feet. Mach 1. Mach 1.1.
Okay, about 10 seconds. We will see the abort.
Abort initiation.
Pyros 1 and 2 discharge both sides.
Good chamber pressure.
Good control. Reorientation. Settling phase. Jettison.
Pyros 3 and 4 discharge both sides.
Squib power.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1, ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.
Seconds, we will see the abort.
Authorization.
Pyros 1 and 2 discharge both sides.
Good chamber pressure.
Good control. Reorientation. Settling phase. Jettison.
Pyros 3 and 4 discharge both sides.
Squib power enabled.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1, ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1, ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1, ignition. And this is the LC. Minotaur Launch vehicle is carrying the AA-2.
VM is go for launch.
Copy that. Check step 96. T-minus 25 seconds. T-minus 20. T-minus 15. T-minus 10. 5, 4, 3, 2, 1. Ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.